Welcome back to my channel. This is much awaited topic. Many of the students requested me to make a video on it. So today I am making a video for you all. The Schrodinger wave equation for a particle in 2D and 3D box. For 1D box we have already done. So first I will write Schrodinger wave equation, time independent Schrodinger wave equation for a particle in 1D box, so that you will get an idea how to proceed for 2D and 3D box. Just a revision of that. Okay, so for 1D box, for one dimensional box, Schrodinger wave equation is d square psi over dx square plus 8 pi square m over h square e psi, because the potential energy inside the box is taken as 0. Actually it is constant, but for simplicity, for simplifying the equation, we take it as 0, and outside the box it is taken as infinite, right? So this is Schrodinger wave equation for a particle in 1D box. Okay, so this psi depends upon only x. Psi depends upon x only. Okay, that's why we write complete differential. Complete second differential of psi with respect to x plus 8 pi square m, mass of the particle, h Planck's constant, E is total energy, and psi is wave function, right? So from this relation we have completed this thing. It is 2 over L sine n pi over L into x, and this L is length of the box along x axis, right? And at the same time total energy we have completed, we have calculated, that is n square h square over 8 ml square. This is the total energy. So this is the relation we have determined, we have calculated from 1D box. That video you can watch, and after watching that video you will come to this. Okay, n is quantum number, and that is equal to 1, 2, 3, so on. Okay, 1 onwards. Okay, only whole numbers, right? Or we can say natural number, because 0 is not included in it. Okay, so this is for 1D box. Now we extend the same to the 2D box. First we will derive for 2D box. So for 2D box, this relation for 2D box, we will get del square psi over del x square plus del square psi over del y square plus 8 pi square m h square into a psi. Now starts the next part, that now psi depends on, yes, tell me, psi is a function of x and y. Last, in the 1D box, psi is a function of x only. Now psi is a function of x and y. That means it has two parts. First, it depends upon x, and second part depends upon y. Psi is a function of x and y. So the part of the psi which depends upon x only, that is capital X, and part of the psi which depends upon y only, that is y. Done? So now when this is the partial differential, second partial differential of psi with respect to x, second partial differential of psi with respect to y. Now this psi is replaced by, psi is replaced by del square x into y divided by del x square plus square x into y, depending on y, divided by del y square, plus 8 pi square m over x square into e into x and y. Right? So now see, this is the function of x. So that means y is constant for that. So y comes out and now it is del square x over del x square. No need to write function of x because it is a function of x only. That's why we write it like this. Plus x outside and del square y over del y square plus 8 pi square m over x square into e x into y. Now let us multiply, take it as first equation, okay, and this one as the second equation. Okay, now divide the whole equation by x into y. Okay, so when we divide it, see, it is divided by x and y. So y cancel, means it is 1 upon x plus 1 upon y, right? And this x into x, y into y is cancelled. So this equation becomes like, right? Got it? Or if you would like to write it once again, so see, it is like 1 upon x, sorry, 1 upon x into del square x over del x square plus 1 upon y square del square y over del y square plus 8 pi square m over x square into e equal to 0. Now see, now after getting this equation, we can write it as 1 upon x, or this total energy is equal to Ex plus Ey, because particle is in 2D box, so energy is divided into two parts, along x-axis, along y-axis. So E can be written as Ex plus Ey. So it becomes 1 upon x del square x over plus 1 upon y del y square equal to minus 8 pi square m over x square into E. So that can be written as minus 8 pi square m over x square Ex. E is Ex plus Ey. So Ex minus 8 pi square m over x square Ey. Now see, on both sides there are two types of quantities. One depending upon x only. Here, this one is the part depending upon x only. This depends on y only. So this is the part depending upon y only. Right? So we can divide it into two parts which are independent of each other and have constant values. So 1 upon x del square x over del x square is equal to minus 8 pi square m over x square Ex. Right? And second part is 1 upon y del square y over del y square is equal to minus 8 pi square m over x square a y. So now again we divide the whole equation into two independent one-dimensional equations. One depending upon x only, other depending upon y only. So we can solve them just like particle in 1D box. So what are the values? For x, wave function, part of the wave function depends upon x only, that is equal to under root 2 by Lx into sine nx phi over Lx into x. Lx is length of the box along x-axis and Ly is taken as length of the box along y-axis. Okay, and nx and ny are quantum numbers along x-axis and y-axis. So this is x-axis. Now y, that is equal to under root 2 over Ly into sine and y pi over Ly into y. Right? So these are the two wave functions, means two parts of the same wave function. And you know, psi xy is equal to x into y. So it is equal to under root 2 by Lx into sine nx into pi over Lx into x into under root 2 upon Ly sine ny pi over Ly into y. Right? So that becomes under root 2 into 2, 4 upon Lx into Ly into sine nx pi over Lx into x into sine ny into pi over Ly into y. Right? So if Lx is equal to Ly, means along x-axis and y-axis lengths are equal and that is equal to L, then this psi xy becomes 2 over L into sine nx pi over Lx into x into sine ny into pi over Ly into y. Right? After getting this value, this is psi xy. Psi xy when Lx is equal to Ly. Right? Now energy Ex and Ey. So Ex is equal to, yes, what is E? N square x square over 8m L square. So it becomes nx square into x square over 8m Lx square, right? And Ey is equal to ny square into x square over 8m Ly square, right? So from these two values of energy along x-axis and y-axis, total energy equal to Ex plus Ey. That is nx square into x square over 8m Lx square plus ny square into x square over 8m Ly square. So that is equal to x square over 8m nx square over lx square plus ny square over ly square. Right? And that is equal to x square over 8ml square into nx square plus ny square, and this value comes out to be like this when Lx is equal to Ly equal to L. Right? So now if we plot a graph between energy versus the energy of different states depending upon nx and ny. So first of all, minimum energy, that is called 0 point energy. So 0 point energy for a particle in 2D box comes out when nx is minimum and ny is also minimum. So minimum value of nx and ny both is 1, right? Because it starts from 1, right? So from this, energy comes out to be 0 point energy. Take it as E0. That is equal to x square over 8ml square into 1 square plus 1 square. So it is 1 plus 1, 2. So value is 2x square over 8ml square, right? That is equal to x square over 4ml square. So this is the minimum energy. And degeneracy of this state is equal to 1. What is degeneracy? Actually, there are different states having same energy. If there are different states having same energy, that states are called degenerate states. Okay, and the number of states having same energy is called degeneracy of that particular state. For example, if we have nx equal to 2 and y equal to 1, or nx equal to 1 and y equal to 2, both have same energy. Both have same energy. It has 2 into x square over 8ml square. If we have state 1, 2 and 2, 1, both have same energy. Am I right? Because it is 4 plus 1 or 1 plus 4. So 5 into x square over 8ml square. Right? So what is the degeneracy of this level? 2. Degeneracy is denoted by G. So what is degeneracy? Number of states having same energy. Okay? So there are 2 states that have same energy. That's why degeneracy of this state is 2. Degeneracy, right? That is number of states having same energy. Okay, and those are called degenerate states. Now next is 2, 2. So if it is 2, 2 means for 2, 2, 4 plus 4, 2 square plus 2 square. So total 8. 4 plus 4, right? 8 into x square over 8ml square means x square over ml square simple, or next is 3 1 and 1 3 and so on. 3 1 1 3, yes. So 9 plus 1 is 10 into x square over 8m l square, right? So its degeneracy is 1, its degeneracy is 2, right? So that's all about particle Schrodinger wave equation and total energy for a particle in one-dimensional box. Sorry, for a two-dimensional box. So we will derive for three-dimensional box in our next lecture. So keep watching and wait for my next lecture. Thank you so much for watching this video. Do like, subscribe and share my channel. God bless you all. Happy learning.